Hi guys, welcome to this set of video lessons. What we're going to do here is we're going to continue in chapter 5 with this idea of polynomials, and again here in what we're in is section 4, further look into this idea of graphing polynomial functions. So back in section 3 we were kind of introduced to this idea of polynomial functions, and we looked at how to evaluate them for both numerical and algebraic expressions, and then we took a long hard look at some general trends that you guys need to know about polynomials and what that means about their graphs. What we're going to do here in section 4 is really sort of get down to the nuts and bolts of me actually giving you a polynomial function and you, having been given a coordinate plane, plotting out some points and graphing that polynomial. Now, the way that we're going to do this, a couple of objectives, learning targets for you before we jump into it here. You will be asked to graph a polynomial function and locate their zeros, right? Stuff that we've done in previous chapters for other things, right? You had to graph and locate zeros for quadratics. You had to graph and locate zeros for linear functions, right? Same thing we've been doing for other functions you're now going to do for polynomials. And then this idea here, finding relative maximum and minimum, what we'll call extrema when we get to them. They're turning points. But anyway, we'll get to that in a second. First, let's start here. Guys, there's really no way around it when it comes to polynomials. It's just going to kind of be the hard-fought table method. I know it's kind of tedious and time-consuming, and it can take a while to work your way through it, but it's the way that we're going to start off here with graphing polynomials. You'll set up an xy table, in this case x and f of x, because that's what we've named our polynomial. You choose the values of x. Remember, you pick the domain values, plug them into the polynomial, and then the polynomial gives you the range value, right? The f of x, which you just put in the chart. These become ordered pairs, x, y. You plot your points, connect the dots, and you've got yourself your graph of your polynomial. I've already worked through this example problem for you. So we'll go ahead and jump to the next page and do one together. One other quick thing I want to point out, we spent quite a bit of time discussing what it means if your polynomial is even or odd degree and what it means if the leading coefficient is positive or negative. So please make sure that you take advantage of that information when graphing these guys, so that you already know what your end behavior is going to be, and you can kind of determine once your table starts heading in a certain direction that, yeah, it's just going to keep going that way. And you'll see here in an exact second when we do an example problem. So here we go. Let's take a look at this one first. I got this really great problem for you here. I've even given you guys a nice little coordinate plane. So here we go. Let's jump right into it. A couple of things I'm going to write down about this guy first. I notice right away 4, 3, 2, 1, 0. It's already in standard form. That means that I know that this is a 4th degree and my leading coefficient is positive. Remember, that tells me some stuff, right? 4th degree means that it's even. Positive leading coefficient, so 4th degree even means both ends go in the same direction, and the positive leading coefficient means that both ends will actually go to positive infinity. So when I get done graphing this guy, both ends of my polynomial should be headed to positive infinity. All right, both ends are going to go up. So that means I can write out this as x approaches negative infinity. As my domain values head in this direction, my function, f of x, is going to go to positive infinity, right? My function is going to be headed this way. And as x goes to positive infinity, as my domain values go in that direction, again, my function is going to go to positive infinity. All right, so all that stuff we learned back in section 3, just going to apply it here real quick just to keep that stuff in mind as I set up my table and run through this stuff. All right, guys, like I said, there's real no way around it. We're setting up a table. You're going to be choosing domain values, plugging them in, and then pulling out your range values. This is going to be a lot of work on a calculator. Please go slow. take your time. It is plug and chug. Once you've chosen your values of x, it'll be plug and chug. Just don't fat finger something on your calculator and you should be okay. I'm going to start at 0. I will go to positive 10 and negative 10. I probably will not need all of those values, but you never know. And you want to make sure, as always, since I've given you a 10 by 10 coordinate plane, you want to use as much of the space as possible depending on your graph. So we're going to start at 0 and we'll go 1, 2, 3, 4, 5, 6, 7, 8. Sorry, I ran out of space. Actually, it turns out that's going to be far enough. -1, -2, -3, -4, -5, -6, -7, -8. Again, I ran out of space, but it turns out that that is definitely far enough. Now, again, I will show you a couple of these just to show you what I mean. I've actually already done them because, again, it's just a lot of plugging and chugging on a calculator, but here's what you're going to do. I'm going to start at, I'll start with 0 and I'll work my way through my table. So the first thing I'm going to do is I'm going to plug in f of 0. Well, remember my polynomial is this guy right up here. So everywhere I have an x, I'm going to plug in the domain value of 0. Which means I'm going to have 0 to the 4th, minus 0 to the 3rd, minus 2 times 0 to the 2nd, plus 4 times 0, minus 6. Right, so I just plug in my domain value. Everywhere I have a variable, it's going to give me my range value, which in this case turns out to be 0, 0, 0, 0, minus 6. All right, let's go ahead and try just a couple more of those so you can see them. If we did f of a positive 1, that means I'd have 1 to the 4th minus 1 cubed minus 2 times 1 squared plus 4 times 1 minus 6. Again, plugging and chugging in your calculator. Positive 1, I get a minus 4. So anyway, like I said, I've already gone through and filled out this table doing exactly that. That's what you're going to have to do. There isn't really any shortcut to it. Like I said, just don't fat finger something on your calculator. Go slow, take your time. And here's what we wind up with. 0 is negative 6. 1 is at a minus 4. Positive 2 gives me a positive 2. 3 gives me a positive 42. And here's what I know. Look at how these numbers are getting bigger. Negative 6, negative 4, 2, positive 42. You notice how those are headed in the positive direction? And since I already knew that as x goes to positive infinity, my function is going to go to positive infinity, guess what I now know? I know that I can now stop. I know that these numbers are just going to get bigger and bigger and bigger as that function, my range values, go to positive infinity. So there's no need to keep going. This guy is clearly headed to infinity and he's not coming back. Let's go the other way. Let's see, negative 1, I get a minus 10. Negative 2, I get a positive 2. Negative 3, I get 72. Okay, so here's what I've got. Once again, I am at a negative number and that number just keeps getting bigger. Again, because of what I know about polynomials and the fact that that polynomial is headed to infinity, I can then infer that this is just going to keep going to infinity. That guy's headed in the positive infinity direction and he is not coming back. Also, these numbers are way too big to graph on the coordinate plane I've given you anyway. So let's plot the ones that we can and get this guy graphed out. 0, negative 6. 1, 2, 3, 4, 5, 6. Got a point right there. 1, negative 4. Right there. 2, 2. 342. I don't know, that's way off the reservation. Let's see, negative 1, negative 10, right down there. 2, 2, negative 2, positive 2. and then -3 again, way off the reservation. So this is going to take a little bit of practice. The more of these you do, the better you'll get at connecting the dots. But you know that, right, these ends, both of these ends are headed to positive infinity, right? They're going to positive infinity based on what I know about polynomials. So that means that this guy's coming from positive infinity. It's got to go through all of these dots. It looks like I'll turn around there and head back in this direction. So again, it takes a little bit of practice, but you guys will get good at seeing these as you get more and more of them. So let me just sketch in a real quick. Again, it's a quick sketch. It's a little rough, but you get the idea. Just connect all the points, both ends, right, headed in the same direction. It's even degree, and my leading coefficient was positive, so they both should be going to positive infinity. I have satisfied everything I know about polynomials in order to get this graph. One other thing I am going to ask you guys to do. Remember, we wanted you not only to graph, but we also wanted you to find the zeros. Well, we talked about this when we did quadratics back in chapter 4. You have a 0 anytime you get a 0 in the y column. But I don't have any. We actually ran into that problem with quadratics as well. What you're now looking for is what we call consecutive integers, which means you're looking for a sign change, right? So right here, I go from being negative to positive. What that means is that right here, I must cross the x-axis, 0. And that's exactly what I see. Between 1 and 2, I cross the x-axis. There's +1, there's +2, and right between those guys, I cross the x-axis. So these are my consecutive integers. Guys, it happens again right up here, -10 and a +2. That sign change means I must cross the x-axis. I got a 0 somewhere in there. And that's exactly what I see right down here. There's -1, there's -2, and I cross between those two integers. So just make sure that you give me those consecutive integers in your final answer when I ask you for them. And it's really easy. It just comes right off your chart. You've already done all the hard work. Consecutive integers, here they are. X is between -1 and a -2. X is less than -2 but greater than a -1, so that's my first one. And then I got another one over here. X is less than 2 but greater than a +1. Again, you just pull those numbers right off your chart to write your consecutive integers. That represents the zeros of this particular polynomial. All right, guys, head on over to the next page of notes and we'll take a look at a couple more problems when it comes to graphing polynomials. I'll meet you there.